Electron configurations. You either know these or you don't know these. Fortunately, however, for those who don't like calculations, there's nothing left to calculate unless, of course, you count adding up to 10 or 5 or whatever to be a calculation. So anyway, select the correct electron configuration for tellurium. Now I deliberately started with this because tellurium is past the A-level specifications, but that's all right because you know the concepts that you can apply throughout. So here's a pretty periodic table. There's tellurium down there. Okay, so what we got to do is somehow get from here to tellurium, or we can use the shorthand, and fortunately they tell us we can use the shorthand because they say, well, here's tellurium here, the previous noble gas is krypton. So we're going to start off with krypton as our noble gas. Okay, now coming down here, we come into the S block. Well, this is part of the S block that A-level says you should know about, but it's not too tough because after all, when you just count all the S's, you start at 1, go 2, 3, 4, 5. So here we're entering into the 5S and we're going to go 2 through it, go through 37 and 38. So there we are. Now we come into the D block. Now, of course, A-level, you just look at the 3D. But there's no reason we can't also look at the 4D, which is where we are here. So we go all the way through the 4D, 10. So now we got 4D 10. And now we enter into the P. Where did the P's go? Well, the first P is 2P. So 2P, 3P, 4P. We're into the 5P here. And we go 1, 2, 3, 4, 5P4. So tellurium, krypton, 5S2, 4D10, 5P4. Now let's look at copper, and this is off the A-level, so we'll give you a reduced periodic table that just includes copper right there. So again, we can go to the previous noble gas, which is argon, so that's what we find in all of these ones. So copper is argon. Come down here into the S's, that's the 4S, so we'll go 2 through that. Come into the D's, and this is the top D, so that's 3D. Go 1, 2, 3, 4, 5, 6, 7, 8, 9. So copper, argon, 4s2, 3d9, you would think. But of course, a filled D subshell is more stable. It gives really extra, super duper extra stability for it. So that means that what copper does is it takes an electron that could have been in the 4s and it pops it up into the 3D. So thus the correct electron configuration for copper, argon, 4s1, 3d10. Atom has a valence shell configuration of S2P3. To which group does it belong? Well, here's our periodic table. There's S2, P3, 1, 2, 3, so it's going to be right there. Which group is that? That is the pnictogens, one of those you don't need to know for A-level, but it's nice to know because it's a good word. Another level of question, how many unpaired electrons in a cobalt atom? So here's our periodic table, there's cobalt right there. So its electron configuration, we start with argon. We go to the 4s, we go 2 through that, and then we come into the 3d, and we go 1, 2, 3, 4, 5, 6, 7 through that. So cobalt's electron configuration 4s2, 3d7, but it didn't care about that. It said how many unpaired electrons are there. Well, we don't worry about the 4s2 because those are filled. But now let's think about putting 7 electrons into the 3D subshell. And by following Hund's rule, we put them in separately. So we get D5 has got 1 electron in each of the D orbitals. And then we put the 6th and the 7th paired up just like that. So how many unpaired electrons are there? 1, 2, 3 unpaired electrons. So what would some call a sneaky question? Which of the following could represent a 1p orbital? Well, what you're supposed to think is, well, that's a D, that's a P, that's a D, and that's an S. So you would say that the answer is B. But the trouble is, there is no such thing as a 1p orbital. Okay, there's a 1s. But then the P's don't start till 2, so there's no 1p. The D's, of course, don't start till 3, so there's no 1d. Or 2D. And the F's, although I haven't put them here because they're very tough to draw, start at 4, so there's no 1F, 2F, or 3F. Bit of a sneaky one, just thrown in there to keep you on your toes.